Hi, this is Randy Miller from StudyCodes.com and the Tech Randy YouTube channel. Today is the first part of the Intro to Programming classes. The Intro to Programming classes are meant more for the beginners that don't know anything about programming. These first few videos will be solely based on the theories, structure, and semantics of programming in general. They will not be including any codes, because I want you to actually understand what you are doing before you do it. One of the main mistakes that new programmers make, including myself, is doing things trial by error. This ends up wasting a lot of unnecessary time that could be used to actually complete the project by doing research first. Like I said though, I too have made this mistake numerous times, and I'm sure you all will do it, and I'll do it again in the future. Before we start, I want to encourage you to start reading the book, How to Think Like a Computer Scientist, the C++ version, which can be obtained freely at greenteapress.com/thinkcpp. Thanks to the author Alan B. Downey. Although I do recommend purchasing the book to not only support the author, but to make sure you give back to the open source community. I say to start with this book because after we complete the fundamental videos, we will start on the C++ classes. I call these classes instead of tutorials because I plan to do this a little differently than your average YouTube tutorial videos. These classes, if you choose to enjoy them, will contain not only lectures, examples, and the source code that I use, but they will also have homework, assignments, projects, quizzes, and tests to make sure that you are actually learning what you need to continue on the programming journey. Also, if you do not agree with what I say, please feel free to comment below. I definitely love feedback from people. Now let's start with some of the fundamentals. There are generally two categories that programming languages are put into, which are high-level and low-level. Low-level programming languages are the languages that pretty much are unreadable for the human eye, and for the majority of people, just a headache. These languages are closer to the computer language, which is why they are called low-level. These languages are called either assembly code or machine language. Low-level programming languages are typically not portable and can only run on a specific kind of computer, since the code and/or memory structure can change depending on the processor that is being used in the computer. When you think of low-level languages, it is closer to the ones and zeros that you see in binary, maybe just a half a step above that. Lower level languages tend to be much faster, but you are giving up the ability to make the application portable from one computer to the other, or from device to device. Mostly people either use these to build kernels for operating systems, or they use them to create specific applications or operating systems for their place of work for special built computers. The other category that programming languages are placed into are called, yep, you guessed it, high level. These high-level languages are closer to human-readable languages so that they can be easily understood by coders. Examples of some high-level languages are Java, C, and C++. There are many, many more, but we would be here all week talking about them all. High-level languages are considered to be portable since they can work on many different computers. As a disclaimer here though, before you get too excited, some programs that work on Linux won't work on Windows or Mac OS, and vice versa. These languages are either interpreted or compiled. An interpreted language is read in line by line, and then it is translated and runs the commands as it goes. Compiled languages are translated all at once. There is a little bit of an argument in the programming community about which is faster and which is better, but this could be up to the differences of how each programmer allocates their memory and how strict they are with processes. There are a few other minor differences, but I won't go over those now. That will be for another video. Compiled languages will go through what is called a compiler. Who would have thunk it, right? This compiler will take in the code files, which are known as source code, and translate them. The source code is the file itself that contains all the pre-compiled code. This will be the code that you write later on. When the source code goes through the compiler, it comes out as an executable file. These are the actual files that will be used to run the program. You see these every day in your start menu or on your desktop. The executable files are the ones that you click on to open the application in order to use it. Each language has its own source code file extension type. The extension is the .txt, .exe, .doc, and so on. C++ uses the .cpp file extension. C uses .c, Java uses .java, and PHP uses .php, just for a few examples of extensions from programming language files. The output file usually ends in a .o or .exe, depending on the language and operating system that is meant to run on. To summarize, the source code, which is the code you created, goes into the compiler. Then it is changed to an executable, which is then executed by the user to enjoy the program. All programs can be built on a foundation of 5 easily understood steps, as put by Alan Downey in the book. Input is number 1, which could be a keystroke, mouse click, microphone. Just think what goes into your computer, then you will probably get the idea. Then number 2 is output. This is what the actual user will see from the program on their monitor or mobile device. Number 3, math. Every program has some sort of math going on whether you see it or not. Processes in the background are doing math without you even knowing it. All programming languages have the ability to do the standard types of math such as addition, subtraction, division, and multiplication. Number 4, testing. There should always be some sort of testing in the process of building an application. This is the only way that you know for sure that it will run the way you want it to every time someone uses it. Number 5, repetition. Each programming language has a way of dealing with repetition, such as counting from 0 to 10. This contains repetition because you are taking the number 0, adding 1, then you get 1, then you take 1 and add 1, then you have 2, and continue this process until you reach the number 10. If you can understand these 5 foundations for any programming language, then you probably have the right to say that you are a pro. Hopefully, throughout these videos, I will be able to help you understand these processes a lot better, and maybe you can teach me a few things too. The last topic that I wanted to touch on from Chapter 1 is debugging. Debugging is the process of removing and preventing errors from messing up a program. These errors are often called bugs. The 3 kinds of errors that you will undoubtedly get eventually will be, first, compile time errors, which are errors that come from bad formatting, problematic syntax, or missing items necessary to compile the program correctly. When I said the word syntax, you might have raised a brow, but don't worry, we will go over it in the future videos since it is a bit more language specific. Just think about syntax as the rules and structure for the code. Second, runtime errors, which are errors that occur when the program is actually running. These are much more apt to happen when you are running large programs and it does stuff like hanging or forced closing. Last but not least, there are logical errors, which are human-made errors from the logic in the programming. These will probably be your most often seen errors. These occur when your logic is off and puts you in infinite loops and such. Well, that is it for Chapter 1. Please let me know what you think of the video in the comments below. And hopefully by the time you see this, the homework assignment video will be posted so that you can give it a go. Remember, knowledge is free, so pass it on.